Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to our YouTube channel Physics Tag. I am Ms. Humaira Ramzan and today we will discuss about the numerical problem of chapter number 4 of 9th class. Okay, let's start. Numerical number 4.1. Find the resultant of the following forces: 10 Newton along x-axis, 6 Newton along y-axis, and 4 Newton along negative x-axis. Okay, solution. We have to draw the vector, and how we can draw it by using head to tail rule. First of all, we will choose a scale. Let's suppose 2 Newton is equal to 1 centimeter. Then 4 Newton according to this scale will be equal to 2 centimeter, and 6 Newton will be equal to 3 centimeter, and 10 Newton will be equal to 5 centimeter. Now draw the horizontal line and vertical line shows as in the figure x-axis and y-axis. The red line shows the 5 centimeter which is equal to 10 Newton along x-axis. The yellow line shows the 3 centimeter which is along y-axis shows the 6 Newton, and 2 centimeter line will show the 4 Newton force along negative x-axis. Now we will draw the resultant vector from join the tail of red vector to the head of the blue vector. The purple line represents the resultant vector, and with the help of scale we calculated it. Its length is 4.25 centimeter. According to the scale, if 1 centimeter is equal to 2 Newton, then 4.2 centimeter will be equal to 8.5 Newton. Here is the result. Also, with the help of protractor, we can calculate the angle. So, with the help of protractor, it is clear that it is making the 45-degree angle with the positive x-axis. Okay, next numerical 4.2. Find the perpendicular component of a force 50 Newton making an angle of 30 degrees with x-axis. Data: force F is equal to 50 Newton, angle is equal to theta is equal to 30 Newton. Now to find what we have to find out, x component is equal to Fx and y component Fy. Now solution. We know that Fx is equal to F cos of theta. Also Fy is equal to F sin of theta. Here F value is 50 multiplied by cos 30. So it's 43.3 Newton, and Fy has a value of 25 Newton. Okay, numerical 4.3. Find the magnitude and direction of a force if its x component is 12 Newton and y component is 5 Newton. Data: x component Fx is equal to 12 Newton, y component Fy is equal to 5 Newton. To find force and angle theta. Solution. We know that F is equal to under root Fx square plus Fy square. By using this formula, we can calculate the magnitude of the resultant force. So, by putting the value, we have the answer 13 Newton. Also, we know that theta is equal to tan inverse Fy over Fx. By putting the value, we have the value 22.6 degrees along x-axis. Okay, numerical 4.4. A force of 100 Newton is applied perpendicularly on the spanner at a distance of 10 cm from an earth. Find the torque produced by the force. Here, the given data: force F is equal to 100 Newton, distance L is equal to 10 cm. First of all, we will convert into the meter. 10 divided by 100 is equal to 0.1 meter. What we have to find out? We have to find out the torque. Okay. Solution. We know that torque is equal to F into L. By putting the value 100 multiplied by 0.1 is equal to 10 Newton meter. So the torque is 10 Newton meter. Numerical 4.5. A force is acting on a body making an angle of 30 degrees with the horizontal. The horizontal component of a force is 20 Newton. Find the force. Data. Angle theta is equal to 30 degree. X component is equal to Fx is equal to 20 Newton. To find force. Solution. We know that Fx is equal to F cos of theta. By rearranging, we have F is equal to Fx divided by cos of theta. By putting the value, we have 23.1 Newton. Numerical 4.6. The steering of a car has a radius of 16 cm. Find the torque produced by a couple of 50 Newton. Couple of a force F is equal to 50 Newton. Radius L is equal to 16 cm. First of all, we will convert into the meter. 16 divided by 100 is equal to 0.16 meter. Now we have to calculate the couple arm. It will be the double of the moment arm. So, couple arm will be equal to AB is equal to 2 into L, which is equal to 2 into multiply by 0.16 is equal to 0.32 meter. Now we have to find out couple of torque. Solution. Couple of torque will be equal to F into AB. AB is the couple arm. So 50 multiplied by 0.32 is equal to 16 Newton meter. Numerical 4.7. A picture frame is hanging by two vertical strings. The tension in the strings are 3.8 Newton and 4.4 Newton. Find the weight of the picture of the frame. Here, tension in the first string is T1 is equal to 3.8 Newton. Tension in the second string is equal to T2 is equal to 4.4 Newton. To find weight, as we know that W is equal to T1 plus T2. Here, 3.8 plus 4.4 is equal to 8.2 Newton. So, the weight of the picture of a frame is 8.2 Newton. Numerical 4.8. Two blocks of mass is 50 kg and 3 kg are suspended by a two string as shown in figure. Find the tension in each string. Data. Mass of first block is equal to M1 is equal to 5 kg. Weight of first block will be W1 is equal to M1G. 5 into 10 is equal to 50 Newton. Here, similarly, we will calculate the mass weight of a second block with the help of mass of the first block. Mass of the second block is M2 is equal to 3 kg. Weight of the second block is equal to W2 is equal to M2G. 3 multiplied by 10 is equal to 30 Newton. To find tension in first string and tension in the second string. From the diagram, it is clear that weight M2, W1 and W2 both are hanged with the T tension in the string 1. So, T1 will be equal to W1 plus W2 and only W2 is attached to the second string. So, the T2 will be equal to W2. Now, we know that T is equal to W since both masses M1 and M2 are attached to the string. So, T1 will be equal to W1 plus W2. It is clear from the figure. So, 50 plus 30 is equal to 80 Newton. Only M2 is attached to the second string. So, T2 will be equal to W2. So, here T2 will be equal to 30 Newton. So, tension in the strings are 80 Newton and 30 Newton. Numerical 4.9. A net has been tightened by a force of 200 Newton using 10 cm long spanner. What length of the spanner is required to loosen the same nut with 150 Newton force? Force F1 is equal to 200 Newton. Force F2 is equal to 150 Newton. Length L1 is equal to 10 cm. What we have to find out? We have to find out L2. Here we know that according to the principle of moment, F1 into L1 is equal to F2 multiplied by L2. By rearranging, we have L2 is equal to F1, L1 divided by F2. By putting the value, we have answered 13.3 cm. So, 13.3 cm long length is required. Numerical 4.1. A block of mass 10 kg is suspended at the distance of 20 cm from the center of a uniform bar of 1 meter long. What force required to balance it at the center of gravity by applying the force at the other end of the bar? Here it is clear from the diagram that center of gravity of the bar, long bar, is at the mid of the bar. So we provide the support at that, and from this mid, we 20 centimeter, we hang the mass of 10 kg, that is m1. So L1 will be equal to 20 centimeter, and from the other end, where the force is applied, the distance L2 is equal to 50 centimeter. It is clear from the figure. The total length is 1 meter, that is equal to 100 centimeter. So mass m1 is equal to 10 kg. From here we can calculate the weight w1, which will be equal to f1. So w1 is equal to f1 is equal to m1g, that is 10 multiplied by 10 is equal to 100 Newton. Now length L1 is equal to 20 centimeter, length L2 is equal to 50 centimeter. What we have to find out? We have to find out the F2. Solution.